present Mr. Andrea Sirk from ALEMO. He is, I would say, one of the persons who is extremely dedicated to foam, as a lot of us, also almost his lifetime. I think it happened by the way that you improved Brazilian machinery first.
Oh, but it started already near 2000 when I take off one company.
Yeah, and the polyethylene foam.
Polyethylene foam,
profiles.
and then trying to, let's say, survive with this, and making improvements, making also because we were near to Italian market. Italian market was a very specific market, dedicated to very low densities, and with high densities, low I mean below of 20 kilos. No? Already at that time was 18 kilos was the normal density for packaging foam. Mm-hmm. And according to this, let's say we have to put the hands in the foam for many
improving more. Yes. Okay.
Trying to find out something. No?
Okay. No, thank you very much for presenting here, and the stage is yours.
Okay, thank you. My name is Andrea Sirk. I'm Doctor Engineer in Chemical Engineering. I started, as I said, already near 2000, let's say, deeply involved in foaming process, in trying, let's say, to make new products and to improve, to change. Dedicated to foam, let's say, since year 2000. Thanks for the opportunity to be here, to have the opportunity to, let's say, try to present some results ALEMO reached in the production of low density foam. I will focus today on the CO2 reduction, not from the point of view of the machinery production, but from the point of view of the footprint the final product makes. Honestly, this job started in year 2000, but was not focused to the CO2 reduction, to the footprint reduction, but was focused on lower cost for raw materials, lower cost for changes, lower scrap, lower energy consumption. But finally, all this is just lower footprint on the product. Actually, this story started in a little bit strange way. Almost 1 year ago, I was really attacked by a friend of mine, doctor in medicine. He was, I don't know how to say in German or English, primario, top of one department in hospital, friend of mine. And I was really attacked by him. That I am a word polluter because I make machinery for plastic, and plastic is just the poison of the world. And I feel badly because, and I started to think on this point and to build some ideas on this point. And finally, the final result is that if I compare, and I will explain how and so on. Finally, the result is that for 1 kilo of foam produced with good practice, with best practice of ALEMO machinery, but actual practice of ALEMO machinery, is saved 0.7 kilograms of CO2 if compared with best practice on other machines. And if I compare totally also with inline, a lot of work we do inline, like inline perforation, slitting, and small rolls and everything. Finally, I can come to this provocative figure of 1 kilogram of CO2 saved for the planet for 1 kilogram of foam produced. And that's the provocative, let's say, result I want to present here. This is the calculation that was done. Finally, we can see here that for 3 kilotons of material produced, more than 2 kilotons of CO2 is saved. The data here on top are from ALEMO Machinery, and this is actual data we measure in companies, taking in account, because the important thing obviously is density, scrap, electrical energy. And this is actual data we take from companies with ALEMO Machinery, as I told, including everything, including starts, stops, including electrical energy break, including everything, but excluding the days or weeks of testing. Testing is out of this calculation. I'm really convinced that this result is consistent, and I'm very proud of it. I mean, how this manage? Let's say, what are the main points bringing us to this achievement? First point is obviously machine around optimal process and not process about existing machine. This is typically in foam production that somebody have some machinery and makes some foam according to machinery he has, but not machinery around the process he has to handle. Minimum volume of material around the process and in the process, because if I have a lot of steel around the process, if I have a lot of material in the process, obviously all the inertias are very, very long. That means stabilization is long. That means that regulation takes long time before getting the actual result. I remember that on old machinery I have been used to handle, and this was counter-rotating extruder, co-rotating extruder, and single screw extruder. But for some products on the edge, we need 8 hours to stabilize, to be sure that we are stable. 8 hours of production to finally reach the stabilization on critical products. It means low density, low thickness, high speed. Obviously, everything becomes more difficult nearer I'm driving to the edge. No? If I want to produce 0.5 millimeter foam, 11 grams per square meter, 3.2 meter wide, at 170 meter per minute, I'm driving on the edge. It's like on the, in the rail. And driving on the edge is difficult. There is enough that something goes out or that something is not under proper control. And then I fall down from the edge. And this is really, let's say, machine around the process, no? Not process around the machine. This is key point. Easy and friendly machine control for line stability. No? We know we have, finally it's easy to make foam. We have to melt, mix, cool, and extrude. Very, very easy. But actually that's not so easy. Especially for different products. When we handle different products, different throughputs, I have to find a good, let's say, balance among the different possibilities the company has to handle. And it's important for us that I mix with the minimum input of energy required. Melt and mix with the minimum of input of energy required. And I have to cool with the minimum of energy I take out from the process. because it's easy, let's say, to use twice the energy I need to mix, twice the energy to cool, because anyhow overcooling is I can handle with higher RPMs. Then I heat again with shear in the machine, and then I cool and I heat. I cool and I heat in the same time. That finally is not only the consumption, electrical energy consumption finally in kilowatt hour per kilogram of product, but is also that all the additional energy I add to the melt is energy that can be used to jeopardize the melt. And working on the edge, we can see on the breakage rate, we can see it on the physical parameters, or finally in the melt strength of the product. That means I have to give just a little bit more of the minimum energy required to melt and mix, and I have to take out just the energy I have to take out from the melt, not more. Whatever more I take is just additional consumption and jeopardizing of the melt. Installation of low energy consumption components, like for example variable reluctancy motors, that because our machines usually does not work on let's say 50 hertz, or on the higher level of efficiency. Usually we work in very different places because we are more interested about the process than on the efficiency of the motors, and then we go down and up with RPMs and whatever. But that's important that I put motors that with almost flat electrical energy efficiency. All small drops, but all these small drops finally make a huge difference, as you know already. This is not. But then we developed software, Foam Track we call. That's really okay. Already since 2007, when we started with the first machine, we started that all the data are in the PLC, not as in the previous time that machines are working with separated parts, separated heaters, separated coolers, whatever. Let's say everything has to be collected in the PLC. Now we come that in the PLC is collected also the temperature of warehouse, humidity in the air, temperature in the production hall, whatever. Everything collected in the PLC and can be seen on the big back of screen, can be collected back in any time. It happened in my experience once that we had at one customer, just for example, this is not related so much maybe, but is process control finally. It happened that one customer had one specific problem with one specific product, but once per week, let's say, and a small problem of a disturbance. We discuss about how they find, let's say, the best equilibrium parameters, not on the, because I drive on the edge, but I want to be in the safe ranges of all these parameters on the edge. And a lot of work was done, but finally we find out the problem only by recalling back the exact moment when the disturbance comes and collecting on the screen all the data of the machine, comparing pressures, comparing temperatures of each heater, of each. Finally came out that there was only in one water cooling unit there was one very small step of 1 degree. When was the problem? There was this step of 1 degree. Finally, looking back, it was one proportional valve that had some, was sticking inside and was not working homogeneously, was making some steps. And in these steps, there was the disturbance that finally made disturbance. And all this is really useful for the good process engineer to handle properly the process then. No? One more thing we did that works really well is the 3.2 meter wide foam. Is going from 2.6 to 3 meter, for example, with the same die. One die is used to make this from 2.6 to 3, and all the different widths that are used in packaging from 1 meter to 3 meters, all these widths are arranged by slitting. And side trimming is also, let's say, lower if I make side trimming on 2-3 rolls than if I make side trimming on each roll. This 3 meter, and as you can imagine, 3 meter foam, 11 grams per square meter, not easy to achieve this homogeneity in the die that finally these rolls are homogeneous, no? Running also at very high speed. One thing that is not in the calculation of 1 kilo per 1 kilo, but could be or should be if we compare with the rest of the world, is 0.5 millimeter protection that is more than enough to protect, for example, furniture plates or so on in packaging. That make 100% the job, but is 0.5 instead of 0.8 or 1 millimeter. One company in Italy, Proxital, they make also these pamphlets that is available for who likes it. Here it's 30 copies, I think. Because making 0.5 millimeter foam, it saves a lot of money in terms of material, but also in terms of transport. Finally, is 1 truck instead of 2 trucks. How much I can calculate this footprint? Very difficult now, because depends where the truck is going and so on and so on. And so. And it's not taken in the account in the calculation, but is 1.2. Then the big automatic winder of 2.5 meters for the finally for the production of material for inline lamination. This big, let's say, winder makes 2.5 meter rolls. The diameter of the roll is 2.5 meter. Inline unwinding on the roll for release of tension in the material for the degassing of the internal layers. This is not taken in account at any way, but for sure, if somebody makes plank from this or from 0.8 meter rolls, saves a lot of CO2 for the planet. And yes, as I said, there is a lot of other things that, for example, inline lamination, then perforation, then this pre-cutting, then small rolls inline, that finally also are reducing of footprint for the plastic industry. And that's, I think that's, finally all this calculation make me happy, because I was so depressed about this attack of the doctor. No? He was really, and I think finally but all of us finally, we are just working the whole day to reduce the footprint for the products we need. We cannot say, let's say we need some products, and we are working whole day to reduce the footprint to have this product by making it lighter, by making it recyclable, by using recycled materials, and so on and so on and so on. That's all. If you have provocative questions, I would be very glad of trying to answer.
Thank you very much for your presentation. I think the numbers have to be reviewed or will be reviewed by one or the other.
Everybody.
Some of them with you. Any questions?
Thanks for the presentation. You talk about the reduction of 1 kilogram CO2 equivalent. What is the reduction in percent?
17%.
17%.
Yes, in percentage. But I like to say 1 kilo per 1 kilo. It's nicer.
No, it's just to know what is the start.
Yeah, in percentage it's 17%, I think.
Okay.
Something like that.
Okay. 17% or is already something.
But yeah, but it's nice to say 1 kilo per 1 kilo.
Always the sales
Well,
person.
more provocative, no? It's more provocative.
Yeah.
1 kilo per 1 kilo, that's really a lot.
Yeah.
70%, okay, it's a lot.
Main topic is the raw material itself, bringing the highest impact compared to energy, compared to processing costs, and so on. So
Yes.
I think there's still such a
The material
big
is
issue,
very
and
big,
so
but
the-
electrical energy is also not
Yeah.
not a deal. It then depends from. But for example, we had one order for some. They do not believe to our electrical energy consumption. We guarantee, and then we make all the testing, and we were below the.
Okay.
But it depends very much also. Let's say if you go to Brazil,
Yeah.
and you talk about electrical energy, they look at you, are you crazy? What's the subject? Because they have electrical energy free of charge, because they have these big dams in the area of. They have these big dams with hydroelectric energy almost free of charge. If you are in countries where electrical energy is really expensive, then everything changes, no? Please.
Yeah, thank you for the presentation. Earlier you talked about having intermeshing, counter-rotating extruders. Can you give more detail? What are the benefits of these types of extruders?
Counter-rotating extruder has some benefits, especially for low density foam. Has the benefit that, first of all, when mixing the product is more gentle, like when you make the bread you can make like this, but you cannot mix in the mixer. If you want to make the bread at home and you mix all the components in the mixer, finally the bread does not get up. Why? Because you jeopardized too much the molecules. Molecules of polyethylene are like, I always imagine molecules of polyethylene like snakes. And all these snakes you have not to break, and you have not even to overmix. Because if you overmix all these snakes, just each snake is closing to itself in a small bundle. But there is nothing keeping together these snakes. And then you can see it immediately when the material comes out of the die, that with the same raw material, with the same so, finally when you go on low density, the material is not is making a lot of waves and so and so. You can see that it's not so that the melt strength is lower.
Other questions? If that's not the case, I would like to thank you again.
Thank you very much.
Also, you get a delicious present.
Thank you. Thank you.